Welcome to this video. In this video, we'll practice using Altair transformations to create histograms, heat maps, and other kind of visualizations. Let's start by importing the package. Once again, depending on the version of Altair, you may or may not need to enable the renders to be notebook. The newest version doesn't need this statement anymore. In this exercise, we will be working with the Gapminder dataset again. Let's take a look at the questions. First, plot a histogram showing the distribution of life expectancy. Use 15 bins. A histogram is simply a bar chart in which each bar represents a category. The height of the bar is the number of observations in this category. If we have a categorical variable, we don't need to do any transformation to create the bins. Let's say hypothetically we want to look at the number of observations in each continent. What we can do in this case, we can create a chart and use the bar graphical mark and then encode the X to be continent and Y to be number of observation. So this is the count transformation. It will simply count the number of observation in each one of these categories. So we get a histogram here. There are many more countries in Africa compared to the other continent. This doesn't quite work well if we have a variable which is not a categorical variable, such as life expectancy. If I put life expectancy here, I'm going to get bars all over the place, and this is because life expectancy is a continuous variable, so there are observations between, for instance, 30 and 35, all different kind of ranges, and in each one of these values has only one observation. We want to group these observations in bins. So what we need to do here, we need to call the function alt.x and pass in life expectancy here. This is exactly the same as saying x equals to life expectancy, but calling the function enables us to pass other parameters. The parameters that we want to pass is bin. So we can pass in the parameter bin to be true, and in this case Altair is going to bin the data and uses some default values for creating these bins. As you can see, it decided to use 7 bins in this case. The question is asking us to use 15 bins. Thus, instead of putting bin equals to true, I'm going to call another function called bin params, and I'm going to specify the maximum number of bin to be 15. That doesn't mean that Altair will use exactly 15 bins, but it will try to create 15 bins using this data. And we get a more granular histogram in this case. The next question is asking us to create a heat map to show the joint distribution of life expectancy and year. Granted, these life expectancies are the life expectancies of countries in different years, and things changed over time. So the value of the heat map is show the distribution of observations across 2 axes. You can think about this as a 3D histogram, except that we use color to indicate the third dimension. So I'm going to start with the same chart, and I'm going to use Y, encode the Y position to be mapped to the year. So let's take out the second Y, obviously is incorrect anymore. And what we get here, we get a bar graphical mark which shows as a square in each intersection of these bins, saying that there are observations in this combination of life expectancy and year. Now that doesn't show us how many observations there are. So what I'm going to do next, I'm going to use the color encoding channel, and I'm going to map it to the count of observations. And thus I get the heat map here. Now, if we take a look, for instance, at this heat map, we can see that early on, year 1950, there are low life expectancies starting from the 25 to 30, and they're not many high. I mean, if you go up to year 2005, 2010, you can see that things have changed, and most observations fall in higher years. Now, Altair created these bins automatically, and we can see that it treated year as a quantitative variable. We can tell it to treat it as a nominal variable, and hence you can see that although it also chose 5 years to be the bin, it kind of sorted the axis a bit differently. So the data type of the variable determines how Altair treats it as well. That doesn't change the underlying picture that the heat map gives us. Early on, life expectancy used to be low, and when things move on, it kind of moved to be high. But still, if you take a look at the intensity of the color, you can imagine that most data were kind of concentrated in this area versus later on it was concentrated in this area in the life expectancies. Next, we are asked to create a horizontal bar chart showing the average life expectancy per continent. So that's very similar to the chart we created in the beginning, except that instead of counting the number of observations, I need to create the height of the bar to be proportional to the average life expectancy. So I'm going to create a chart using the bar graphical mark, and I'm going to encode my X to be continent. Next, the height of the bar should be proportional to the average of the life expectancy. I'm going to use the average transformation to get that in. The question is asking us to create a horizontal bar chart. This one is a vertical one, so I'm going just simply to flip the X and the Y. The next question is asking us to sort these bars by height. So we want to start the continent with a higher life expectancy in the beginning. So this is basically the same chart, except that I need to provide extra parameters when it comes to sorting on the y-axis. I'm going to use the function alt.y, and this function enables me to provide extra parameters. The extra parameter I want to provide here is sort. I'm going to create an encoding sort field that uses the average operator on the field, which is life expectancy. And I'm going to make the order descending in this case. So now the bar chart is sorted on the y-axis, and the sorting was done by looking at the field life expectancy, calculating the average, and sorting it in a descending order. Let's take a look at the next question. The next question is asking us to create a bar chart showing bars ranging from the first quartile to the third quartile in each continent. We want to sort by the median life expectancy. So the idea is very similar to this one, except that we want to show the range of life expectancies per continent. So if we look at this chart, we can see that continents such as Oceania and Europe have a higher life expectancy, for instance, than Africa. But we want to take a look at the range as well. So this one is very similar to this one, except that instead of using just the X, I'm going to use the X and the X2. So the X here would be the first quartile, and I need to provide X2, which is where the bar chart, the bar itself ends. So once we provide X and X2, the chart no longer starts from 0. It will start at X and ends at X2. So I'm doing two transformations here, Q1 and Q3 of life expectancy. The question is also asking us to sort by the median. This one sorts by the average, so I'm going to change this one to the median. If we take a look at what we get here, we get a chart, bar chart similar to this one, except that the bars do not start at 0, they start at Q1 and end at Q3. So that shows the range of life expectancies across the continents. So not only Oceania and Europe have higher life expectancy, for instance, than Asia and Africa, but also the variance is much lower. Countries seems to be more homogeneous when it comes to life expectancy compared to Asia, Africa, and even the Americas. The last question is asking us to indicate the median in addition to the range. And the way we're going to indicate the median is by adding a tick corresponding to the median on each one of these charts. So because we're using Altair and the graphics, the way to create this chart is basically to overlay two charts. This one, so I'm going to call this one chart 1. And I'm going to create another chart called chart 2. Now chart 2, in contrast to chart 1, is going to use the tick graphical mark. And in this chart, I'm going to leave the y-axis to be the same, the continent. My x is going to be the median of life expectancy. So obviously this chart is not a chart we want, it's an intermediate step. It basically shows the median as a tick. What we're interested in at the end is to put chart 1 and chart 2 on top of each other. So I'm going to put chart 2 on top of chart 1, and what we get here, we get the range in terms of the quartile as well as the medians all plotted on one chart.